Okay. Still let you know I'm still not feeling too well. So today's office hour, we're still going to do online. Okay, stay a little bit from me. I think I have allergy because I have had allergy problem for many years. So it shouldn't be contagious, but just to be safe. Okay, so let's do the today's office hour via Zoom instead of in person. Okay, so what I'm going to do today is starting introduce homework 3. Oh, it's not there. I was wondering what's going on. Okay, so we're going to start talking about homework 3. Homework 3 has a few components that you learned recently. We're going to extend what we did for homework 2 and make it more useful, or maybe make it more applicable to more realistic situation. For example, we're going to introduce, I'm going to focus starting today on 3 different GitHub directory, CPP07, CPP08, CPP09. The source code's there, and I want to tell you what it is. So CPP07 is introduced the basic, very simple form of what we call RPC, which is remote procedure call. I'll explain what it is, but you should have already installed all the library in homework 2 part 1, which you already have the right implementation to do that. And CPP08 is based on RPC, but it's introduced a concept called remote object. So let me tell you that what's the difference between remote procedure call and remote object. So remote procedure call means that instead of calling a function in the same program, so when you do the compiling, the second stage of compiling is called linking. When you link all the library and all the .o file together, you're having one single executable. So when you make a function call, or sometimes we call procedure call, you're actually calling the memory space within that single program. That's traditional, single executable. That means this executable, during its execution, during the runtime support, is sharing a single memory space. I mean, when I say memory space, later you take the course ECS150, when you learn about operating system, you will have a more specific idea about what do I mean now, say, sharing the single memory space. In fact, technically is sharing the same virtual memory space in terms of modern operating system like a Mac or Windows or Linux. Okay, but what is remote procedure call? Remote procedure call is basically saying that I'm calling a function, but this function is at a different memory space instead of the same memory space. So if you compile 2 programs, they're both executable. These 2 programs are not sharing the same virtual memory space. They're actually having 2 separate memory space layout. And therefore, when you make a function call, you're actually calling, remote procedure call means that you actually go remote to call a function that's actually in a different program, which we will talk about that. I mean, for example, in homework assignment 2, part 1, remember you have to compile. One is a client program, one is a server program. So they're both independent programs, but somehow the client can interact with the server. That's because client and server are two separate programs, which means that they have a two different virtual memory space. So the function, residency and things like that are a little bit different. Arrangement is a little bit different. Okay, that's the first thing called JSON RPC. Okay, we can extend that concept a little bit into what we call remote procedure call. Sorry, remote object. That's CPP08. That's the topic I hopefully can cover either today or by Tuesday. So remote object is essentially saying that, okay, I want to interact with an object. So usually when you interact with an object, this object is in the same memory space, so you can interact with that. But now in this case, the object is also in a different space. So remote object means that you try to interact with the object, but the object is remote. And how do you handle that? And then the CPP09 I consider is a very useful concept. Is called proxy object. So if you think about if you think about the following scenario, CPP08, we talk about remote object. That means the programmer need to worry about where the object is. Okay, so when we talk about separate virtual memory space or different program, there's immediately a responsibility of the programmer, because programmer need to know where is the other program, because I want to go there to call a function. I want to go there to invoke a member function for that particular remote object. So which means that the programmer need to have some mechanism to actually find out whether that particular remote object is in Davis, in Sacramento, or is in Toronto or Paris or Beijing. So the thing is that it's actually could be everywhere in terms of program. That's the power of a network programming, that you can interact with any object, any place that's connected to the internet. Okay, so what is a proxy object? But we want to reduce the responsibility of the programmer. So the programmer doesn't need to worry about where the object really is. Where means that which program outside. But instead, I just simply call a proxy, which proxy will automatically resolve to find the right place, the right program to actually call. This is very convenient as a programmer, because now the programmer only need to worry about how do I focus on interact with the object regardless its current location, and I can do that. And in fact, the concept why I'm introducing the proxy object right now, and the reason we do that right now, because it's using virtual function. Okay, so virtual function is polymorphism. That's virtual function, by the way, is a C++ way of implementing polymorphism. Polymorphism means that when you call a function, that this function might behave differently. So here in this context, polymorphism means that I actually want to call a function, but the thing is that I don't know where the object really is. I don't have to know. I don't know where it is. So I just call it. The virtual function mechanism will automatically resolve the difference. And then it will find the right place to call, and such that I will get the result. And sometimes I'm actually maybe calling somewhere local in Davis, but sometimes I'm actually calling somewhere in Alaska. I don't know. Okay, so that's the three directory we're going to learn. I hope I can cover a majority of that today. But anyway. Okay, so then let me introduce a little bit about, I'm going to introduce a little bit starting for homework assignment number 3. That the first part of homework assignment number 3, you can see that I want you to do exactly what you're doing with homework assignment number 2, part 2. Exactly. But we want to do it in a remote procedure call fashion. So if you think about what you're doing is that your homework assignment number 2, part 2 is that you're giving 2 JSON. One is called location JSON. One is called question JSON. And this to JSON is enter your program, and then your program will calculate what's the location that this particular timestamp for this particular location traces. Okay, so over here, we actually changed this a little bit, but this change really makes sense. Okay, so we're going to separate the program into client part and the server part. So the client part is to still play the role of submitting the location traces or submitting the question. But the server part is really do the bookkeeping about all the location and to answer the question. So let me use the following example to contrast the difference, because this really, in some sense, I feel you will see that why remote procedure call is useful. In your program, you have a one single program for homework 2, part 2. So you have a traces, which call the location, whatever you have been. So there's a few assumptions you need to make. The assumption number one, the traces has been sorted according to the time. The second thing is that the traces is really for only one single person. And the third one is the traces, you cannot submit more. Because if you think about realistic, like a Google map, this kind of application, I need to continuously submit update for my traces, right? I need to submit that. And so the thing is that you realize that this service, in order to be practical, it has to allow multiple update about the traces. And I will allow multiple person to upload their traces. And I'm allowed to have different questions regarding all the traces. And that's certainly, if you look at your homework 2, part 2, it's so limited. I'm sorry to say that. It's simple because this is probably first time you try to do this kind of programming. It's simple, but it's really limited in terms of doing the things we just talked about. So now why I said just simply separate, become the client server, we resolve all this issue. Okay, so the server program becoming receiving the trace. And the server program, the beautiful thing about the server program is running 24/7. Okay, the server is running over there 24/7, so it can receive multiple updates. So now you have the client program. And the thing is, guess what? You can actually repeatedly execute your client program with different traces you want to update. So for example, today, I want to submit my traces. So I server is running, let's say Google. And the client is my smartphone. I actually run my client. I update today's all my traces. And tomorrow I want to update it again. I run the client again. So instead of thinking about running a single program, you kind of separate client and server. You really allow one side of the program to be running all the time, where the client program, you can incrementally update all the information you want to update. And the other thing is interesting is that in the single program is usually one user. But last time I mentioned, if I want to trace a bunch of UC Davis user in terms of the spread of some pandemic disease I want to track, which means that I want to have a single server somewhere on campus, assuming we have a privacy protection. That's always have to say that. And then each of the students can run the client program and submit over there into the server. So the server has the aggregate information about a lot of traces belong to a lot of different users. And then the server can actually do more powerful computation based on that information. Okay, so transition from homework 2 to homework 3, that we like to introduce you the concept, not only thinking about how to do this in programming, but think about that why this architecture makes sense when you design an application. Okay. Okay, so so the first thing I just want to tell you is that I do have a bunch of reference programs that help you kind of learn some of the concept. How do we change that? It will be provided, and under the master directory, ecs36b, I will put the master directory there. And the format of the location changed a little bit. I make these changes because I want to introduce identity. So previously, the location trace is only the second part about the latitude, longitude, and time. That's all we did, right? An array of location and time pair information so we can have the traces. But now we want to introduce a concept identity. We want to say, well, who actually submitted? Because of the remote procedure call, you can imagine you only have one server, but you have billions of clients potentially are submitting the information. And I want to know what that identity is. So this is a very simple form of a tracing. So we just introduced another key value pair called identity, and okay, so don't put your real social security number, okay, or student ID in this program. That's a really bad idea. We just want to know how it works. So we just put virtual ID like what I did here. 8123455, whatever. Okay, so just be sensitive when we do this kind of programming. We kind of learn a little bit about how industry is potentially tracking what we're doing. On the other hand, when we're really doing this ourselves, we need to be sensitive to this issue. So just putting some random stuff there. Okay. Okay. Later, if you really join the dark side, you can think this differently. Okay. No, I'm kind of kidding. Okay. I always teasing students about the dark side of computer science. All right. So this is the new format about the location. So this one is let me see, do I have here? So I already have this here. You can think about this is HW3 location.json is here. And then, sorry. And then HW3 question, and the question is the same, right? Question, I have the attribute. I have to add the attribute identity because when you submit a time, you want to see where this person is at this time. So of course, you have to give me the identity so I know who you're talking about. So when I have identity, I basically allow multiple users sharing a single server for this particular location tracing service. Okay. And the thing is that I introduced a new class called time location, timed underscore location. I introduced a new class. So I feel this is a little bit easier to be more consistent with the rest of the program. So in homework 2, part 2, reference implementation, what I did is I have a struct, I think I call homework 2 item. I kind of changed that to make a real C++ class. So this is if you look at the time location, it's the same structure, but it's a more object-oriented. It has a GPS, it has a JV time, have a constructor, and it has this two virtual member function. One is called dump to JSON, one is JSON to object. So far, we just start to talk about dump to JSON. And so JSON to object is a major piece of hassle. I have to wait until later to talk about probably your homework assignment number 4. The last programming assignment is related to JSON to object. So essentially, what dump to JSON is that you have a C++ object, you kind of dump the content. So you have a JSON. But the other way is that if I give you a JSON, can you restore a C++ object? That's the other way. Okay, so one way is dump to JSON is you convert C++ to JSON, and JSON to object is converted back. And if you can do both ways, you really reach the world easily with two different concepts. But this part is easy because C++ is a strong type language, sort of. Okay, some people will argue it's still not strong enough, but it just has a type of language. But JSON is completely no type. There's no, I would say, you can have anything defined as any key value pair. So therefore, when you convert it back, you have to do a lot of checking. Okay, whether this has this, whether this has that, and then this will raise a lot of exception. Because what happened if you want to convert the object, you realize it doesn't have this, it doesn't have that. And then remember the original class might have a virtual function, polymorphism. And then with that, with casting as well. And then so when you actually convert it back, how do you precisely convert it back is a really, really challenging task. Okay. Nothing is perfect, but you will learn not just exceptional handling can be used, but also think about a really some kind of type programming language versus something which is the compiler doesn't do anything, which is JSON. Oh, by the way, C++ program, at least you need to go through the compiler. JSON, you just write it there, and then there is no such things called like object-oriented programming compiler will help you to do that check. Okay, so I introduced this new class. I have already done all the coding, so you can use this as for your homework 3 as well. By the way, any program on the GitHub, you can use it. That's not considered copying, and this is a teamwork. Okay, team project. Okay, so just to let you know that if I ask you this, if you download that program, I already update the make file as well. So if you not this one. Not this one. Where am I? Okay. So just to let you know, this is the first program, just ecs36b homework 3 reference 01. I have a multiple reference code. This one just show you how to use the new time, the time location class and how to handle the new format of the JSON, the new format adding the attribute identity. So you can see that I get rid of a lot of stuff. There is no longer the struct homework 2 item. I just include the class definition called time location. But inside here, you can see that I need to check whether it has an attribute identity, whether the name is traces and things like that. But then at the end, it's still the same thing. I'm still running the difference. At the end, I'm still there's another major difference I want to tell you. Is in homework 2 part 2 reference implementation, I use traditional C array. But in here, I'm using a standard template library in C++. We will cover all the standard template library later, but the most popular template you need to learn is called vector. So it's equivalent of array, but look at this line. This is how I declare a vector. So I say std vector, and the vector is array. Array of what? Array of time location, which is the new class I define. And then the name of the vector is called HW3TL, time location. I call it vector. Okay, that's the terminology of So once I've done this, the usage of that is really similar to the array. Let me actually show you, for example. When I try to use let me see, where do I do this? Here. You see that? I just basically say HW3TL vector I dot dump to JSON. Okay, just like the usage is very compatible, but there was a few differences. Number one, with C++ vector, I don't need to worry about malloc. I don't need to worry about allocating enough element. That's the big improvement. If you remember the reference code, if you actually look at carefully, at one point, I have to calculate how many elements I need to allocate. And then I can malloc that element. You should compare the ecs36b HW2 ref.cpp with ecs36b HW3 reference is 0.1. If you compare, contrast these two pieces of code, you will see that the usage about C++ vector is similar, but somewhat different. Okay, but at the end, it still calculate the time diff. So if you do a make, okay, it's already make. I think let me just make it again. So now you see it's compile whatever, and then it's compiled. This one is compiling ecs36b HW3 ref1. This is including also the, where's the time location? Here. Time location.o is here. Okay, meaning that it's already included these things together. And then if you execute the program, looks like this. Now you see that I'm running this program, but I'm actually using HW3 location.json, HW3 question.json. And when I run it, you see you're getting exactly the same result, more or less, right? The difference is the output is almost identical to the to your homework assignment number 2, except when you look at the question, you see that has an identity there. And when you look at the location JSON is also have identity and trace, the new format. And then I kind of adjust the reference implementation a little bit from homework 2 such that it will process the homework 3 JSON, those two JSON appropriately. Okay. So that hopefully gets you some idea about what you need to do homework 3. So at this moment, you should start with homework 3 part 1 and starting to look at how do you do, okay, by the way, homework 3 part 1 is asking you to do essentially functionally exactly the same as homework 2, but you're using remote procedure call, okay, and then the new format. All right, so let me now let's go to discuss about the CPP07, CPP08, CPP09. Those three are 3 directory under the repository. You can just click the link to go in there. Okay. Okay, I want to arrange this a little bit. I thought I already have it somewhere here. Okay, anyway, I'm going to, oh, I cannot use this window. Okay, I will use this window. CPP07. Okay, let me try to first show you what you at least, without looking at the detail, just how do you use CPP07, and then from there we go back to look at this program itself. Okay, so of course when you download the directory, you type make. Okay, and you can see that when I make this stuff, I already have the JSON RPC server. Those things you should have already installed when you finish the part 1 of homework 2. Okay, after you've done this, I'm going to create 2 programs, because if you do an LS, you will see I have a 2 program. One program is called WR server, and the other program is called WR client. Okay, I have this 2 program. So so always use 2 window, 2 terminal to do that, and always run WR server first. If you don't run WR server, if you directly run WR client, it will tell you, you will get this error message say client connector error. So if you saw this, that means the server is not running. Okay, could not connect to whatever the HTTP link, the URL, which I actually specify in the program. I'll show you the difference. Okay, so we didn't run the server, so I actually run hw/wr server. If I run WR server, now I run client again. So it actually get a result. This is really just looks like when you do the participation, when you have that successful, when you do the team registration. In fact, I'm using this program modified to such that for your whatever, when you do the team submission. Okay, so that's the style. You can think about, okay, why is this? Is I'm running a client program need to call a function in remote in the server. And if the server is not running, of course, that one will fail. But when it is indeed was running, then I actually be able to get the result. And this very simple case, it says status successful. Okay, so that's how you run the program. Now let's actually take a look inside. By the way, before I push further, any question? Everything good? Okay, all right. So let me, I want to bring up a slide if I can find it. Sorry. I believe 6 and 7 must be. I want to just bring one picture about remote procedure call. Okay. So now I want to kind of show you what is the general idea of a remote procedure call. So I kind of already mentioned that, the concept orally, but let's just refresh our concept. The top is a traditional procedure call. Okay, you actually call a function that's in the same memory space. You share the same memory space. But now we have to split such that we have a two program. This program obviously is a client in this picture, and this is a server. So the function is really running on the other program. Okay, so it was developed by Sun Microsystem, later being merged by Oracle. So it has a different implementation of RPC, but lately that there are two most popular RPC protocol. One is JSON RPC, one is gRPC. So JSON RPC is the one that I'm trying to cover in this class. And gRPC, when you hear anything with G, you probably can guess what that means. G means Google. So Google RPC. So why gRPC? Why Google developed gRPC? Because with JSON RPC, everything got encoded into JSON. So JSON is very user-friendly, and I can actually read what it is using my editor, whatever viewer. But it's not as efficient. If you really care about performance and memory management, then gRPC is a better choice to do that. But on the other hand, you lost some advantage that you have with JSON. Okay, so I just want to let you know. I mean, industry, they're using RPC is a huge amount of RPC. I mean, I don't know if you remember this complaint by Elon Musk when he first acquired Twitter. He actually has some complaint about engineer discuss, and you can still Google it. And he said the problem Twitter is slow is because the performance of the RPC, the remote procedure call, that when they try to do the connect information. Okay, so just to let you know, we're learning JSON RPC, but instead of a style, it's conceptually is the same as gRPC. But the thing is that depending on your purpose, if you really want to do a huge amount of information to process, you probably want to choose gRPC. But if you want to do a small amount, you want to do debugging, maybe JSON RPC is more popular in this case. Okay. All right. So here is what the JSON RPC is going to do. So JSON RPC provide you a program called JSON RPC stub. JSON RPC stub. So essentially what you have is that you need to specify the calling interface between the client and the server. And that program is specified in the JSON format. So let's go back to the program. Let's see what is that program. That is that interface. The interface is defined over here. You see that ecs36b wr.json. That's the specification I was talking about in the slide I showed you. So let's actually take a look at this. Not here. So, okay, this is the program. This is the specification of that RPC spec. Over here, it basically say, hey, I define a remote function called remote print. Remote print, that's the name of the function. And this function takes two arguments when I call it. One is called action, one is called your JSON. And then it will return whatever specification. It's also a JSON. So what is a JSON RPC? JSON RPC is using JSON to specify the interface about the client and the server, but they also use JSON to actually encode all the information from parameter to return value. Everything is JSON. So that's why it's pretty user-friendly in terms of you can read it. Okay, so this is the example. I only have one function we need to implement. But let's actually take a look at another example, which is show you a slightly more complicated. For example, this is your master directory. Let me see. What do I have here? I forgot. Okay, let's look at the JSON here, 2024.json. So in this JSON, this particular scenario has two functions. You see that there's a first function called update, and the second function called search. So update is upload information, search is searching for the information I need. So you can actually have a multiple function defined for one particular RPC scenario. So let's actually come back to this slide. So the spec I just showed you is what we call the specification of the interface, which is the file. And then this file will go into this program called JSON RPC stub. And JSON RPC stub will generate two .h file. One side is for the client. There's a client.h file. One side is the server.h file. And then we still need to write the .cpp file to go with it. And such that because think about that specification provide how this client server should interact, meaning that what's the data format they need to interact, which means that the way they interact is being encoded, or some of this code program is encoded in the code that it generates. Okay. Conceptually, is this okay? Do you understand what we're trying to do? I'm going to show you the code. Hopefully, you will understand it better. But at least you know JSON RPC stub is reading that JSON file and generate some kind of supporting code for the client server to be able to work together. Okay, let's go back to this one. This program, you see that you have all the program. Let me make it clean again. Okay, I want you to know is that I have a WR client.h here. I have WR server.h. If I make a clean, you will see that those two files are gone. Those two .h files. So I no longer have WR client.cpp. I no longer have WR server. So if I look at my make file, let me see if I can trick this program to do that. Oh no, my make file is doing well, so it won't. So what happened is that if you want to compile WR client.h WR client, it will need WR client.o, right? It will need to have the WR client.objective file. But if you think when I compile WR.o, it actually depending on WR client.h. Okay. However, you see that a little bit top. I have another rule called WR client.h, which depending on ecs36b wr.json. So you see that here I'm actually calling the function JSON RPC step. And the first parameter is that ecs36b wr.json. And this program will actually generate that .h file. Okay, let's try to run this program. Now you don't have anything. So let's try to make it. Take a look at the first line. The first thing it did is actually generate the WR client.h and WR server.h. After they done that, they try to compile WR client. And then they actually compile whatever this one is generating the executable. So this first three line, understand the first three line. The first line is generating the file according to the JSON RPC protocol, generates .h file. The second line is actually compiling, not linking, compiling the WR client.cpp program to get WR client. And the third line is important, is really doing the linking. So I try to emphasize the concept as a programmer, especially C++, you really should be sensitive to what you're doing. Are you just doing compiling, checking syntax, or are you doing linking? Okay, so this one is doing linking because it's essentially generate the executable code WR client, but look at everything is linking. WR client.o, which is already compiled, is an object file. And then the library JSON CPP, the library micro, whatever. The rest of the line in the make file, everything is a library, has already been compiled. So this one is really doing linking. So that's why homework 2 part 1 is important, because you have to install all this library on your environment, and so you will link appropriately. Okay, so that's the first three line. Okay, so now if you take a look, now you see that right now after that I have WR client.h and then WR server.h. Let's just take a look at the code itself. So if you take a look at the code essentially is saying that, okay, this is generated, don't modify. And it's generated code has a class called WR client. Is inheriting from JSON RPC client. And inside here, that it has a constructor, but then it has a function, remote print. That's a function that we specify. And take a look at what happened. Take a look at what happened, because this piece of code is generated. This piece of code, remote print, it basically encoded your two argument, which is, by the way, the argument is action is a string, and your JSON is also a string. Okay, this is two string, and then you essentially encoded this into your key value pair. That's and then remember this P is really your parameter. And then what you need to do is, this is the line that's really called remote. This call method is going to call remote print, which is the name of the function, and the parameter, which is P. Okay, so this is the real line that's actually generated. You will release your control of the program to a program at remote, and until they respond. So when they respond, you will get a result. And that result is also in JSON format. Okay, so JSON RPC essentially everywhere is JSON. Okay, the specification is JSON, the encoding of the parameter is JSON, and then the result is also JSON. Okay, and that's a code that's generated. Okay, so let's actually take a look at the .cpp. Let's take a look at how it's being used. Okay, so this is the code that we have to write when you want to do remote procedure call. So, okay, I have to include, by the way, you have to include this three line, probably not the first line. If you, this first line, probably if you include ecs36b common, that should be there. But you need to include WR client.h, and you need to include the standard JSON RPC CPP HTTP client. So essentially, what we're doing right now is doing web browsing. We're doing web browsing. We're doing HTTP. instead of using Firefox or Safari or Internet Explorer, we're basically using our program to do the browsing. And all the information is changed between the web server, which your server is actually web server, and your client is the browser, but now is a C++ program as a browser, okay? Okay, so I have to set it up. So this program is really short. First, I have to set up what is the web address, the URL I need to use. So in this case, I'm actually, because I know I'm running on the same computer, so I just say HTTP localhost colon 830. Okay, so that's just the first part is the URL. The second part is what we call the port number. So there are a few standard port number which I typically try to avoid because I'm actually want to have my own port. This is, by the way, a little bit about security, that you can actually have a two program, your own program, but they're following a different port number such that it will introduce extra effort for the hacker try to go into your program. Okay, so here you see I'm using localhost 83, but just to tell you that if you remember what we did with the King program, I put it here, and the RT client.cpp program, it's the same structure, but over here you see that the HTTP client, I'm actually set it up to be ethicus.ngrock.io. That's the web link that's actually configured to my computer. So I'm using a service called ngrock, which I can specify a link to my project. And so the way it works is that your request, when you submit the client program, it will be redirect from ngrock to my computer using the server. So you can see that it's just a way, how do I connect with the computer I like to connect? Okay. Okay, let's come back to the client program again. Let me do Emacs. Okay, let's parse through this few lines. I think we're fine. So I specify the client, and I have to also create a JSON RPC, which is my client was the class. I just WR client. So WR client was the class that in the WR client.h. And there's a few JSON. So I just want to print something. So in this case, I just say, hey, my JSON contains a key value pair. I want to just have the remote print. This is the test. So by the way, if you come to the remote is actually printing content. This is the test message. Okay, so that's exactly what we expect to happen. Okay, and now is the exciting part. You configure your parameter, and now I just basically print it. So I basically say my client.remote print, and then put the parameter remote print and whatever string I want to print. Okay, and that will work for the remote. Okay, so this basically say, because let's actually take a look. Let's just follow what is my client. What is my client? So my client is WR client is here. And the first parameter of my client is HTTP client. The second part is just a version number. So the second part is actually kind of not really important, but the first part is important. And what's HTTP client? HTTP client is here. It's actually linking to the web URL. So when you actually call, say, my client.remote print, you're actually using this my client and using that HTTP client to get to the other side. Okay, that's how the mechanism. Okay. Any question? Completely lost, or Was I crystally clear such that you don't need to ask any question? I'm actually suspecting it's the first. But anyway, I'll let you pause for 1 second, and I want to come back to here, actually. Okay, so WR client, if you take a look at the remote print, you see that it takes two arguments. Both of them are string. Okay, both of them are string. And so that's why here, both of them are string as well. Okay, by the way, in this case, I don't think I need to use C string. I think I should be fine without C string. But anyway, I did that when I did the programming. Okay. Okay, I want to shift a little bit to compare another thing before I finish this part. So if you look at the ecs36b wr.json, you see when I declare the parameter action and your JSON, the way I use it is just double quote. Double quote in JSON means string. So that's why we generate code. It will generate code, say the two argument has to be string. So both of them are string. That's why it actually chooses the string. But if you go to the Ting program we run before, if you look at the way I define, no, it's, what is my RT, let me see, ls star.json. Is this the thing? Okay, so I have a JSON called ecs36b rt.json. So you see that I did a little bit different here. The first action is still the string. But the second part, your JSON, I actually encoded, say, hey, I want to communicate as an object instead of string. I mean, I can do that. In fact, I actually prefer to communicate with object whenever it's appropriate. So when you generate the code, rt client.h, you can see that it generates, the first one action is a string, so still generate std string. But the second argument, it actually generate your JSON as JSON column value. Okay, it's generated because I specify as object. That's how it connects. That's why when I try to use it, it's very similar. When I call it, you can see that when I call this function over here, the function name is called register team. The first argument, the string, it says register team. But the second argument is I just simply put my JSON because it is a JSON value. So I just put it there. So I want to say that as a programmer, as a JSON RPC programmer, you have the choice to define what kind of parameter you would like to encode in the function call. And it will follow that file to generate the code, whatever fit your need. Okay. All right, that's probably conclude my introduction to CPP07, which is the basic JSON RPC. Just making a function, okay? Nothing particularly complicated. Any question? Okay, so just please feel free if you get lost at a very early stage, just let me know so I can revisit some of the concept. So I'm going to CPP08. So again, CPP08 is a remote object. So what's the difference is that CPP07 is, oh, no, I have to go back to CPP07. I completely forgot. I just show you the client. I never show you the server. But the server is actually the most exciting part. So let's take a look at the server. Let's try to run it again. Okay, the server is here. And let me run the server. Let me go back to modify next. P. This is another test message. I can, or ecs36b spring 2024. Okay. Okay, I'm going to run the client. Forget it. Okay, when I run the client, now the server is basically say, hey, this is the new message I just update. Okay, so I pretty much went over all the client side of the operation. Now I want to shift to the server side. How do you actually develop the server side? So let's take a look at the server. Okay, the first few line is pretty standard. It's just adding the header for JSON value and the JSON RPC C2P header. And over here, again, you need to include the file WR server.h. Okay, just like the other program, you have to include WR client.h. By the way, most of the code, if you include ecs36b comment.h, it should include all the include for the first 5 lines, or maybe even for this line, but not this line. You always have to update yourself. Okay. All right. So this part just include. Okay, but this is starting the interesting part. So I declare in the server side, you need to declare a class called, in this case, I call it, you can decide whatever name you want to choose. I call this my WR server, which is a class. And this class inheriting from another class called WR server. Okay, so high level structure, I have to have a class, and then it will inherit from WR server. Okay, we'll explain why you have to be this way. But inside this, I have two functions. Again, one is constructor, and the other one is called remote print, which is the function that's, we have the same, exactly the same format from the client side as well. Before I introduce you WR server, I like to go through the rest of the code so you know how server is being constructed. So the constructor is, typically I don't modify the constructor except the name because it's pretty standard. For remote procedure call, these two connector and the type are associated with the RPC protocol. So typically I don't change anything. I always use the same format. But the only thing is I need to worry about is this code is my remote print is the function, depending on how many function I try to do. So similarly, you can see that the input parameter of the function is still those whatever parameter you define as the specification of the JSON file. Okay. And okay, now let's actually take a look at this. Inside here, this part is, I just want to, by the way, this part of code is about timing. Okay, I just want to basically at least print some time about when I actually receive this request. Okay, so if you take a look at this, you see that I actually log some information. The remote print is printing this one, but I actually remember the time because at the server, it's always good to have a way to track or log whatever request you receive from the client. And based on that information, and I might be able to do debugging, or based on that information, I can resolve some situation which I need to realize that when did it happen. Okay, so that part is not necessary as a server, but in practical situation, a server always log enough information so you will be able to handle certain kind of unexpected situation. So this part of the code is just basically handle the timing. And then this part of the code is basically handle the return. I said status successful. Remember, we saw that from the client side when you run the program. And this part of the code is actually try to parsing the JSON. Okay, try to parse the JSON. We typically, now we have the code called ecs36b JSON, which is kind of hide all this detail about how to do JSON in terms of function. So we have things like my file to JSON or my JSON to file, and we have my string to JSON. So over here is essentially included like the function called my string to JSON or my JSON to string. Okay. And after you've done that, let me see, where is that printing? I want to say, where is that printing go? This part is, okay, I want to say this line, the action, whatever, this line is corresponding to this block of code. Okay, this block code just say remote function, what's the action? Remote print. And then inside this is a JSON. So I just print that. And then I have this timestamp, which is this part is timestamp being printed at what time. Okay, so those two already done. The printing part up to this point is already done. And below is just handling the return. Want to respond back to the server. So I know what I want to return. I want to return string JSON, but I need to use this piece of code to encode that string back to JSON so I can send it, because the result itself is JSON. It has to follow JSON format. So that's a string converted to JSON. So that's why I said when you do your team participation credit, I kind of modify to JSON, because then I don't have to do this conversion because it's JSON already. I can just return that back. Okay, so it's sometimes you have to know what you're doing, decide what's the right choice about the data type. Okay. Okay, so that is a very simple implementation on the server side. So by the way, just to let you know, this particular function, remote print, when the client make a call, if your JSON RPC protocol is specified correctly, then this is the function will get invoked. Okay, this is the function going to be invoked when the client come over here. So, okay, so the rest of the part is the server. The standard server is the main program. It's a different program. So we're going to have a two main. One main is on the client, the other main is on the server. So let's think about this. In this, what is a server? You have to start yourself. It's a HTTP server. HTTP server has a port number. I specify 8300, which is the port number on the other side. I set up a server. I'm using this line to actually create my WR server. So after this side, I kind of set up my server. And after that, I actually just start listening. You see that this is important. Okay, at the server, you have to let the whole world know that now you're ready to receive requests to handle. You have to say, I start listening, because the client could be coming from any part of the world. So I'm just opened up, I'm listening this particular port, whoever can deliver to me, and I will be able to. After this is nothing to do with your program. It's just the web protocol, web server. So after I say start listening, any request will directly go to that particular function, like a remote print. Okay, so that's, you can see that the server part is not that complicated in this case. Just this few line. Okay. Everything good? Anything confuse you, or you have a question, or no? Just scratch your head. Okay. Okay, I mean, my recommendations for you to kind of to verify if you're completely lost, please contact me. I'll be happy to explain in a different way, or maybe in another way, try to give you an example. I'm always happy to do that, or the TA can actually talk about that as well. But if you already got the concept, but you really want to say, hey, I want to know whether my understanding is actually what happened, I would suggest you to download the code and just try to modify, try to play around. Sometimes you can actually intentionally introduce some error and let your server crash and things like that. That's actually always a best way to learn programming. Okay, do it yourself. Okay, just let you know, this program is under the GitHub directory, CPP07 JSON RPC. Okay, okay. Now I can move to CPP08. So the difference between CPP08 and CPP07 is that CPP07, I just define a function to let you talk to the other function. But CPP08 trying to say, hey, I have an object. I have an object in the server. And you would like to directly call a member function of that object. In this case, it's a C++ object. And how do we do that? Because we're writing C++ program, you can imagine that in the server side, you have billions of objects of any kind. So in other words, I'm actually allow my C++ object on the server to be directly interact with an object, with some piece of code from the client side. So let's take a look at the, again, we have to take a look at the JSON interface. I call it ecs36b ro.json. Okay. You know what? I want to run it again. I want to run the program first. Make it clean. Again, if you take a look again, I don't have ro server.h. I don't have ro client.h. These things are automatically generated. Okay, I'm running with all my whatever class I need, and then I have a client, I have a server this way. Okay, so let's build the server. So again, I have to run server first, and then I'm going to run the client. Okay, so you can see that now I kind of have a more information which I want to explain. That is when your client program is interact with the server program in a more object-oriented way. Okay, if you take a look at the server side, is actually having some kind of object, which that object is labeled GPS object in this case. Okay, so that's the printout. Now let's okay, now let's actually take a look at sorry about that. I'm just my throw is not 100%, so that means from time to time we'll do this. Okay, so let's do the client side. Let's first look at the interface. I have 6 minutes. Good. Okay. So we're going to actually see some virtual function. Maybe this one the next time. So I have two function defined. One is called set GPS label, and the second function is called dump to JSON. Okay, I have two functions. One is called set GPS. But over here, when I try to do this, I have defined the interface as action, which is just like last time. But over here, because it's an object, I have to let the remote to know that which object I would like to interact with. Okay, so you think about that, the function is just one single function. But now I want to be specified about which, because the server might have a 1 billion object. So which object is really I want to interact with. So the parameter, I have to provide two extra parameter. One is called class name. One is called object identity. Means that under which class, under which object identity, and then the real argument to that member function is this label. Because remember, this function is called set GPS label. Okay, so that's the set GPS label, how it's configured. Let's take a look at dump to JSON. Dump to JSON doesn't have any argument, but it still needs to identify which class or which object identity. That's why it has action, which is the function name, which is dump to JSON, and the class name is class name and object ID. You still need object ID, okay? So this is two function, one take one argument, one take zero argument. I just specify the function I would like to call, okay? Okay, let's take a look at the client again. Okay, so this is the client program. You will see that the first few lines, it looks really similar. Looks really similar, except instead of RW, now I'm doing RO client. And the main program at the beginning, this view line looks really similar to each other. Okay, it is whatever the URL and the server side, whatever declared. Okay, and then I'm actually going to call this function. Okay, at this moment, I call dump to JSON. I said, well, remote object, I'm going to call a function called dump to JSON. And the class of that object is going to be labeled GPS. And the object identity is 1001. And of course, because dump to JSON doesn't have any argument, so that's only 3 arguments over there. And I'm printing the result. And then the second one I'm calling is set GPS label. So the action is set GPS label, and then the class is labeled GPS. And then there's a teaching and learning complex and 1001. So have you noticed that the order of the argument is a little bit different from what I described before? So let's take a look at this closely. This is something as a programmer for JSON RPC, we need to be a little bit careful. Not the best design. Okay, so let's take a look at this. So I declare 4 arguments. Over here is action, class name, object ID, and label, right? I have a 4. So first is action, and then is a class name, object ID, and then label. But if you notice the difference over here, it is, I need your help, okay? To remember, the first one was this. This is action, right? This is a class name, but this is really the label. And this is the object ID, right? So they flipped the last 2. And why is that? It's because alphabetic order. Because JSON, in fact, it doesn't have any specify any order. So essentially you put 4 pair of a key value pair. From the JSON perspective, there is no order. So they're equivalent. So you can shuffle the order, doesn't matter. But what JSON RPC did is they actually take the key value pair and follow the alphabetic order. So the first one is action, the second one is class, and the third one, alphabetic order is not is not object, it's label. So label become number 3. And then object ID. How do we do that? We have to take a look at the .h file. This is generated code. If you take a look at the code it generates, this is the code it generates for set GPS label. Take a look at this part. The first argument is action, class name, label, and object ID. So as a programmer, we have to sometimes take a look at the exact order of the argument that's actually provided by the code, the JSON RPC stuff generated. And then when we call it, then we will call it correctly. Okay, if you actually miss this and you kind of call it in a different way, you actually will see the result is incorrect. And sometimes this is something we have to debug. Okay. I think I'm going to stop here. This is just at the end of my class. But we will continue this on Tuesday. Okay, next Tuesday. You have a good weekend. Yes, please.
Was alphabetic order the functions or the like
the alphabetic order of the key value of this for. So that's a good question. Let me go. So if you take a look at this specifies the parameter, right? And it has a 4 element. That means it's a 4 parameter in the function, right? So alphabetic order means the key. The key is this: action, class name, object ID, and the label. So even though when I specify this JSON file, I kind of have O and label, place that order, but they will pick the compiler, JSON RPC stuff program, when they generate the code, they actually look at the key and then shuffle the order. Okay, it's not our job, it's they generate the code. So sometimes we have to look at their code, see what happens. Okay. Okay, let me turn off the recording first.